Hello everyone, welcome to our pre-calculus pre-recording video. This is about one-to-one function and its inverse functions. As I said, at some point in between the discussion of exponential and logarithmic function, we will discuss this topic, and this is actually very useful when we discuss logarithmic functions, and if we want to connect it with the exponential function, you will see that these concepts actually very helpful. So that is the objective in our mind why we are discussing it. That is the reason. But also it will actually help you to understand in general what is this one-to-one function, what is its role, all this kind of thing, or what it does actually uh, in terms of functions, graphs, ordered pairs, maps, etc., etc. So let's look at first thing, concepts of functions and one-to-one functions discussion. In general, what is a function? How do we know that something is a function? And how do we define something as one-to-one function? Or how they are different? This is a function, one-to-one is also a function. What is their difference? If we want to understand it, then actually we can look back the definition of function, and then of course we will come back to the one-to-one function. In the function, we know that the function can have, for one x value, let's say you have, if I draw a graph, let's say you have some quadratic function graph, let's say you have some cubic function graph. Let's say you have some other graph, something like this, all these kinds of graphs. Okay, so a function, we are talking about the function. A function tells us that for one x value, if you have only one y value, for one x value, suppose this is 1, and let's say you have 1 here, that means for plus 1 you have only one y value. For minus 1 you have maybe plus 1. For plus 1 you have 1. For minus 1 you have also 1. So, but for 1 you do not have two different answers. For 1 you have just only one answer. Okay, let's show you in contrast what happens. Suppose here you have also 1, but you have two answers for this 1. One is downside here, one is upside here. So here for 1 you have two answers. One answer is let's say minus 1, another answer is plus 1. So you have two different answers. And function, the definition of function tells us that this kind of situation is not allowed, is forbidden in function. For function, one x value can have only one y value, but different x value can have common y value, no problem. That definition of function tells us that. So by that definition, this is a function, this is a function, this is not a function. Okay, because here also you can see these they have just only one value, these they also have just only one value. So this one is a function, this one is a function, and this one is not a function. Okay, now which one is one-to-one function? Notice that this one is common here. Okay, but if you look at this kind of graph, for 1 you get 1, for minus 1 you get, in this graph you get minus 1. So you see, they are different here in this case. For one-to-one function, you will see this kind of scenario. This is an example of one-to-one function. 1, 2, 1. Okay, from the name also, each of the x value, they have distinct y value. Even 2x value cannot have same y value. 2x value cannot have same y value. Y value has to be different for the one-to-one function. So basically what is happening, we are imposing just one more condition in the function. This is one-to-one function. Of course, this is function also. This is function and also one-to-one function. But this is a function, but not one-to-one function. Not one-to-one function, this one. Not one-to-one function. Not one-to-one function. This is function and one-to-one function. One-to-one function. Both. Okay, this is function and one-to-one function, both. And this one is not a function, not a one-to-one function. This one is very poor. This guy is very poor guy here. Not a function, not a function, not a one-to-one function. Okay. We have more clearer definitions coming up. Just we are giving concept here. Okay. So this is how we understand like what is going on. How do we understand? Just in your mind, think it this way, that I should not get any common y value to get a one-to-one function. Okay. For example, here your y value is common, same y value you get. Okay, for different x values. Here it will be like all different. All different. We have more techniques, they are coming up, so let's go. So first of all, here, which one is function, which one is one-to-one function, and which one is not? This is called mapping, from mapping. Notice that I think you have the answer in your mind already. Think about it. What can be a function, what can be one-to-one, what can be this and that. I think you have noticed that this is actually function and also one-to-one function because all are distinct and no problem. And this is a function because we have no problem. They are different. Like duck has only one output. Lion has only one output. Pig has only one output. But duck do not have two different outputs. Suppose if we say that, what is the life expectancy of dog? You cannot say life expectancy of dog is 11 years and 7 years because this is ambiguous. You cannot say that life or average life of a dog is 7 years. Then you're gonna average life of a dog is 11 years. They're ambiguous, right? They're ambiguous, kind of. So this is actually this is, if it goes at two different paths, then it is not a function actually. Like this example, this is not a function. This is one-to-one function and also a function, as you know. This is just only a function but not one-to-one because you have common y value. Okay, and this is even not a function because you have common x value here. Not a function. Okay, this one is function but not one-to-one. Why not one-to-one? Because you have common y value. Common y value not possible for one-to-one function. Okay. So here is the definition. For any function, each x input value can have only one y value. Okay. For one-to-one function, this is the function, and for one-to-one function, each y value, output value, can have only one x value. For any function, each x value can have one y output, but they can have common. You can just write in bracket here. They can have common y value, no problem. Here, just the extra condition is they even cannot have common y value. This is their difference. Okay. Actually, this also means that y value, each y value can have only one x value. That means actually they cannot have common y value. 2 or 3 y value cannot be there. Like they cannot have common y value. Like this, they cannot have common y value. This 10 is common for 3 of them. So this is not possible in the one-to-one function. So this is how we understand. Now from a graph, how do you understand? Like, is this one-to-one function? First of all, this is a function, because for function we do a vertical line test, and if you draw a vertical line test, then it will be a function, because then you have, if you draw a line, your line intersect your graph at only one point, then that means it is a function. For function, what is the test? For function, vertical line test. Vertical line means you draw a vertical line. If your graph is intersected at your line only once, then it is a function. Let me give you an example of when it is not a function and how do we know from vertical line test. Just our previous example. Here, if you draw a vertical line, then you see on the graph you have two intersections. On the graph you have two intersections. That's why it is not a function. And your vertical line test tells you that. Okay, so vertical line line test is helpful. Now for one-to-one function, here you go. We have, why is it coming? Okay, we have horizontal line test. Now you draw a horizontal line. If your graph intersect at two different points, then this is not one-to-one. Not one-to-one function. This is not a one-to-one function, but this is a function. This is a function. We know it from vertical line test. This is a function, but not one-to-one. How do we know? By horizontal line test. Horizontal line test. This is not one-to-one function. So what will be one-to-one function then? Remember, we have drawn this graph. This is actually cubic function graph. This is one-to-one function. How do you know? Draw a horizontal line. See, only at one point your line intersects the graph. So it is one-to-one function. So it is one-to-one function. It doesn't matter where you draw it. Everywhere it actually happens that way. Okay. So this is one-to-one function. This is one-to-one. This is one-to-one, but this is not. Okay. So this is how we understand it. This is written here, horizontal line test. This is not one-to-one. So which one is one-to-one? Which one is not here in the given graphs? Even there are like examples of not a function. Think about it. I think you have some idea. Think about the vertical line and horizontal line test. Horizontal line, for first of all you define that is it a function or not. First, number one is that. If it is a function, then go for is it a horizontal? If it is a function, then go for is it one-to-one or not. Okay. So this one is function, but not one-to-one, because it will fail the horizontal line test. This is not even a function. That's why there is no question for one-to-one. This is a one-to-one function. This is actually from my given example. Okay. Why do we care about a function is one-to-one or not? Here you go. Because a function, if a function is one-to-one, we can find the inverse of this function. Inverse of the function. What does it mean? What it does? See, the domain of a one-to-one function becomes the range of the inverse of that function. We can easily find out the inverse function if we know if it is a one-to-one function. The domain of the function, the domain of a function, domain is the x value, so first line is the domain. So domain of this function will become the range of the inverse function. See, this was in the x value, now this became y value. In our first function, this is the y value, and in our here in the second case, this has became the x value. So one-to-one function helps us to construct the inverse function very easily. Very easily. Okay, so we understand it this way. The domain of the inverse. Let me give you just a simple just let me tell you simply what is happening here. Suppose if you have um, let's say if you have 6 comma 2 comma 3 comma 5. Suppose if you have just only these 2 points, the inverse, this is a function, let's say this is a function, the inverse of this function will be, this is not hard, you will see this is super easy. 6 is first, 2 is second value here. They will swap. X value will become y value, so it will become 2 comma 6. That's it. This is 3 comma 5, so it will become 5 comma 3. Then this is the function. This is the inverse. This is the inverse function. Or someone can say, sir, if this is my function, and isn't it then the inverse? Answer is true. If you say, okay, this is my function, then this will be the inverse. So basically what happens? The value just interchange. X and y value the interchange. Now let me show you. This is so fun. Let me show you this. Suppose you have a point here somewhere, let's say 1 comma 2 or 2 comma 1. Let's say 2 comma 1. 2 comma 1 is here. Now if I ask you what is the inverse of this point, I think within a second you know the answer. Inverse of this point is 1 comma 2. The point is here. Okay, this is the inverse, 1 comma 2. This simple, not hard, okay, not hard. So we have example here, next page. See, they are inverse of each other. This is A3, B2, so B3, A2 will be the inverse. This is the concept from the book. So basically if you join all the line, this is like, if you join all the points, then you get a curve. So if this is a function, this will be the inverse function graph. See the extension of the concept. We can actually extend the concept to draw entire inverse function graph. Okay, just you interchange the value, x value and y value, then you get the inverse function graph. This is what it says. If you have a comma b, it will become b comma a in the inverse. Okay, and the graph is, the inverse function graph is symmetric with respect to y equal to x line. It has a symmetry with respect to y equal to x line. Symmetry means if you consider a mirror at this y equal to x, then you will see this point in the mirror here. All of this is like a mirror reflection. This point you will see in the mirror. In the mirror you will see this point here in the mirror. Now you can say, sir, what does it mean that I will see this and that there in the mirror when it is not a mirror? Suppose, okay. So let me extend it. Suppose this graph from here, it goes there and it goes here. Now you see, this is okay, fine. This line and this line in the mirror. This point mirror. This point mirror. But how come this point comes here in the mirror? Because this has to be like something like this, right? Mirror means exact same thing, exact same copy it will show. That is mirror. You stand on the mirror, then what it shows? Exact same who you are. Okay? So mirror reflection means it will show you the exact same thing. If you consider the mirror is where? Mirror is here. This is what is called y equal to x symmetry. Mirror, that means mirror is at this line, y equal to x line. That is the mirror. So you will always have this y equal to x reflection. So now this is x cube graph. What will be the inverse? Just you interchange all of them, then you draw it. you get their inverse, and you see this is the mirror. So on the mirror you will see the reflection. On the mirror you will see the reflection. Now, what about if you have some given equation? What can we do about that? Notice that we already learned that x and y value interchange. So let's say if you have if x equals to twice x plus 3, first of all, this is the equation y equal to twice x plus 3. Then switch x and y, because we know that x and y will switch. So x equals to this and this. Now solve the equation for y. That means y equal to what from here? This is very simple calculation. You send this 3 in the other side, then y equals to this divided by 2. Very simple calculation here. From this line, y equal to what? So it will be twice y plus 3. Suppose twice y plus 3 equal to x. Then twice y equals to x minus 3. Then y equals to x minus 3 divided by 2. And it is written here separately, x by 2 and minus 3 by 2, which is possible here. Then this is the inverse. F inverse of x basically is this thing. You could write just simply f inverse of that is x minus 3 divided by 2, because this and this means the same thing. So what you do? Very simple. You interchange x and y, then solve for y equal to what? That's it. That's it. Okay, that is your inverse function if the equation is given. Then we have more practice. This is the practice items. We plan to you give a try to practice all of them. Here it is like in the problem. This is determine whether the function is one-to-one. Try to find out if it is one-to-one or not. Then we have then here determine is it one-to-one or not. They said also to draw the vertical line test or horizontal line test. You know what to do now. This is like drawing the inverse of these functions. Drawing the inverse of these functions. So we plan to solve this kind of maths during the class. Also, you can give a try to solve these maths before the class even. Since you are watching the recording, so you can just solve that. And these are just like evaluate exponential function, graph exponential function. This is the reading part. Try to read that. This is actually review reading, and try to draw a lot of exponential function graphs. Lot of exponential function graphs. Let me give you some example. What should sharing is paused? We don't have a problem. Exponential function graphs, a lot of exponential function graphs. Suppose you try to draw 3 to the power x equals to what? Y equals to, then y equals to 3 to the power minus x equals to what? Draw the graph of this. Y equal to minus 3 to the power x equals to what? Y equal to minus 3 to the power minus x equals to what? Y equals to 3 to the power x, then plus 2 equals to what? Y equals to 3 to the power x, then minus 2 equals to what? Y equals to which one? And then combined 3 to the power x minus 2, then plus 1. This graph equal to what? Try to draw this graph in your copy, in your notebook. This will help you. Okay, and then inverse. If you will not have to draw all of them. It's better if you can draw all of them. Then try to draw their inverse. This will be a little crazy when you start with these graphs, but still this will be helpful. You'll see all these things actually helps in the process. At least everyone should draw these four graphs. At least draw these 4 graphs and their inverse. Okay, this is, you should do all these things before we start something new. Something new means logarithmic function. You should draw all these graphs. And also even for exponential function transformation, exponential function better understanding, finding the equation, matching the exponential graph and the function. These 4, some people say, sir, I do not understand this and that. Sir, I do not understand the transformation. The reason is you do not know the building blocks. This is the building blocks of the exponential functions, that graph and equation. You must first of all know that what is the graph of 3 to the power x. Do you understand? 3 to the power x, 2 to the power x, e to the power x, their shape is same. So once you know one of them clearly, then actually you know others also. In your mind, see, if you know 3 to the power x, then you will know 2 to the power x equal to what? Automatically you will say, oh, 3 to the power x graph is this. This is 3 to the power x graph. And 2 to the power x graph shape is also same. Also same, not like this. Some same, okay? They are same, just only this will decrease little bit slowly, increase little bit slowly. Then y equal to e to the power x, e to the power x. See, once you master a set of graphs, then actually you master a tons and tons of set of graphs. Because here the value is just 2 is different. The e value is 2.718, so basically it is just a constant number simply. Although it looks like, oh my god, what is this e? Equal to 2.718, we will use this value. This is Euler's constant. So this is also a very significant number in nature. Anyway, so that's all for today. This class, this is the reason why I'm saying this to draw, because this drawing is important, okay? And we will connect all this drawing later with our other concepts. So if you are shaky in this drawing and in this thing, then you will face problem in the coming class, okay? So that's the thing. All right, so that's all for today. Thank you all. Thank you very much for joining, and have a good day. See you all in the class. Bye bye.